This is Scott from Atomicorp. Today we're going to be covering, we're going to be extending our session from last week where we were doing malware reverse engineering on the malware we captured in the wild. We're going to be applying, moving sort of on to the next level of that, which is going to be into countermeasures using a tool called ClamAV, which is an open source AV scanner. In the near future, well, just some housekeeping. If you have questions, you can always ask them in the Atomicorp support Slack. I am doing my best to monitor the Rocky Linux security channel when this goes on, but it's hard. Our MC here, Charity, is always available is always keeping an eye on these things, and you can certainly ping us in the chat here. Next week, we will not be having a session because I'm on vacation, unless somebody else from our team here wants to do one. That is completely open to anybody who wants to do presentation.
Yeah, Frank.
Yeah, Frank. Totally open if you want to do it. You know, I got a lot of folks ping me on the Rocky Linux security channel that wanted to revisit the malware reverse engineering, which I thought was fun. We're going to do that again. In fact, yesterday, I connected up with the MITRE ATT&CK folks. They, welcome if you're joining us. And they actually had a particular piece of malware that they wanted to do, which is actually leveraging. They have real samples, and they're leveraging the eBPF functionality in the Linux kernel, which is a very, very hardcore piece of malware, and it's a very unique attack vector. So I'm pretty sure we're going to do it again. I can't imagine we won't be doing more malware research. I had somebody else in the Atomicorp support channel has who hasn't joined us yet, and if he does, let me know, Charity. I'm looking for Rajesh from the support channel, but he had some malware that he's capturing in the wild on his system, which could also be fun to look at. So at any rate, we're going to move on into something a little more hands-on, which is, you know, we did analysis of malware. Now we're going to get into a way of detecting and preventing. So this is called ClamAV. ClamAV has been around in the open source community for decades. In fact, it is the very first open source package I ever packaged, going back to 2003. It runs on legacy Unix systems, so AIX and Solaris and HP, as well as Linux, and on Mac and Windows. We're going to be focusing this on Linux. A lot of what we do here is Linux centric, and some of the unique things that you can do on Linux with it, which is pretty cool, and it's definitely going to be a topic of some stuff in the future. So let's kind of break down what it is. It is an AV engine. It supports signature. It's a signature-based system, right? So, you know, all well and good. AV systems do that. These are the various signature types it uses, but the one that I think is really unique and deserves its own topic is called Yara. That's Y-A-R-A. And Yara is more of a generic malware description language that can be carried across different malware, you know, or counter malware tools. So Clam is one, but you can do Yara signatures in mod security. You can use them in all sorts of other tools out there. They tie into SIMs, and so it's you know, sort of like a portable language. But other things you can do with ClamAV are very simple signature-based detection, which we talked about last week, where we look at hashes. Hash-based detection for malware it's as a bad guy, it's pretty easy to beat, but it is very cheap, computationally wise to implement. And when we get to the end of this session, we'll make some simple signatures using hash-based models. Basically, would allow you to generate very quickly, without having to understand the more complicated languages, very quickly be able to create a signature for something. Now, I've used ClamAV in a couple of different scenarios. I've certainly used it to find malware, but I've also used it to find files, right? Like totally non-malicious stuff. I create a signature for it. I just want to find all the files that are blah, and you can search through. So some of the other functionality in here, it has much more advanced detection systems where we can actually do binary analysis. And those rules are, I'll be honest, I've been working with this for better part of almost 2 decades now, and those are hard to write and really hard to teach. So if we do those in a session, it'll be a very hardcore session and a lot of me pasting stuff into Slack. It was tricky. So let's kind of move on into something a little more hands-on to make this kind of practical for everybody, so you can quickly get a feel for this. So CLAM is available for in natively in a lot of the package repos. This is our malware research system running on Fedora. But if you are on CentOS, Rocky, Red Hat, this is the exact same, nearly the exact same process. The package is available in those platforms in the EPEL repo. That's EPEL or EPEL. On Fedora, it's just native in here, and pretty straightforward to install. This is the exact same installation procedure for all of those platforms. This is available on Ubuntu and Debian as well. I think they, I'll have to look at my notes, but they call the package names, which is pretty close. And let's break down what I just did here. So I grabbed three components here: ClamAV, ClamAV Update, and ClamD. ClamAV, you want all three because they contain different function areas of this. If you look at the full suite of the stuff that's in the ClamAV package, there's a lot, right? You've got Milter and file system and devel and things like that. But the long story short, we want to grab these three. The reason why is the ClamAV package contains the real-time AV component, which is the much more interesting thing. We'll get towards this in later sections. ClamAV Update, that's how you get your signatures, and then ClamD is the service, right? The service itself. So let's kind of go in real quick. I'm going to paste what I'm running here into the Atomicorp Slack channel, the Atomicorp, #Atomicorp and Atomicorp Slack, what I'm doing and the steps, and maybe we'll kind of compile the stuff later on. At this point, we're installed. The second thing is to know where the configuration files are. If you don't know where the configuration files are for any package, and you're using an RPM-based platform, you can always use the RPM command like this, QL, and then that'll give you a list of where the files are. Pro tip, I just grep for Etsy, and you'll see that there is in the ClamD package, or one of them. I know where it is because I've been working with this for nearly 20 years, but let's see what package that belonged to. Yeah, it's probably one of the edge case ones. There you go. ClamAV file system. That's where that guy lives. So the core config file in here, we have two components. We have an updater, and then we have the service config. Step one is always to add your sigs first, your signatures first. We're going to use a tool called FreshClam to do that. It's going to reach out to the internet and grab these guys. It has a service. This can run as a daemon and automatically update itself, or we can run it, the way I'm doing it right here. You can run it through cron. I like to run it through cron because I just don't like to see lots of spurious processes on my servers. And those are the basic signatures in here. There are other signature feeds, and we at Atomicorp make one, but the very minimal, you want to have these guys in here, and that's our list of AV signatures. The second thing is we need to always configure something on ClamAV because for the most part, it never comes out of the box fully functional. Number one, and this used to be the default, was this line right here. If this is uncommented, it won't start at all. But the only one I know for a fact I need to play around with on here is to set the socket. It's just hiding down here. Here we go, TCP socket. We'll get into why we're doing this here later on. We just want to get straight into what we're editing here to start it. The layout on Ubuntu is slightly different. I think they use etc ClamAV in their environment. If there's enough interest, we can always revisit this on Ubuntu later on. Oops. I am pasting this into the Atomicorp Slack channel. scan.conf. And all I'm doing here is just telling it to listen on a specific port. And at this point, we can start it up. Oops. There we go. It's ClamD, not ClamAV, Damon. The good news with this is that when this was originally implemented, like depending on the distribution, the version of the distribution you were on, the startup with this was completely different. This is standardized now from Red Hat 7 up to 9. It's all the same, and obviously in Fedora. Okay, so let's kind of go over the ways that ClamAV can be run. It has three methods, right? There's what I call standalone, which means there's no service required. In fact, I'll stop the service and we'll to demonstrate this. There's the daemon model, right, where you've got a server called ClamD that's going to handle these requests, and then there's the inline system, which is called on access, which we'll get to here in a second. So let's start with ClamD scan, and we're actually going to look at the malware we captured last week. But we're not going to do it as root. We're going to run it as a regular user. And this was our malware content in 2 formats. This is going to be unique because I know I tested it on the original malware, right? The original malware that we captured in the last week's session. But if you were here for that, we uncompressed it, and I'm going to be into this file right here. And I'm curious to see if Clam will capture it. My guess is going to be no. For reference, this was what the response was in VirusTotal for this specific malware that I'm about to scan with Clam. And you can see it already knows, right? It knows this one right here. So as a double thing here, I'm going to do Clam scan on Linux, and I'm going to time it so you can see why you would use it standalone versus why you would use it as a service. It comes down to one word: speed. So the service itself doesn't give you any extra detection capability, right? There's nothing special about detection. It's just faster. That took 12 seconds to run, right? We'll run the same thing through the daemon. It does take a little time to start up, by the way. So be sensitive to that. But we'll see that this will just bam hit it real fast. And the reason why that's good is the speed. The reason why it's bad is if I look at the largest memory consuming process, that's real resident memory consuming process on the system, it's 1.2 gigs, right? So that there are plenty of very good reasons, memory-based reasons, to not yet run this as a service and just eat it and live with the fact that the scan time for this was 12 seconds versus the scan time when I run the client version, where it ran in, well, it hasn't finished started up yet. That's why it errored out, but it'll run considerably faster. In fact, while we're waiting for that guy to, because that's a slow VM, I'll just scan it on this guy over here. So we'll do clam scan first. Do I have clam scan on here? Watch me not have it. No, I do. So clam scan on an eCar test signature. This is nice because it's telling me how long it's taking to load the signatures. It's loading that 1.2 gig or whatever file into memory. So then, and then it's doing what's what we call a just-in-time compile, right? So that ran in 14 seconds versus this guy right here, which ran in 0.014 seconds, right? So the point is if you're trying to do this on any kind of where latency matters, ClamD is the way to go. If you don't care, then you'll save yourself a gigabyte of memory here by not doing that. But let's test this again on. Let's see. You guys, are you done starting up yet? No. Let's test this again with ClamScan on the malware we extracted yesterday. Now, my guess is this is probably not going to get anything, unless they wrote a secondary signature for this uncompressed, or they did it. Oh, look at that. All right. That will be interesting. That might be fun to take apart. So yeah, it captured it. Now it captured it with a different signature, or the same signature. So their signature for the compressed one, yeah, it's a different signature. And we'll do that again. We'll do it on the back. I can just do them both at the same time. I'm gonna stop using ClamAV scan. I use ClamScan. Yeah, I'm not surprised by that. So probably if we look at their signatures here, which we'll get to in a second, I'll bet you that they're just two separate hash-based signatures on these two. Yeah. So we have two separate SIGs, which is cool because, this one might actually have more info on that one than this one does, because I can tell by this number that it's an older signature. So if you have an older signature, sometimes that means that the data about it might be richer. Maybe. It might not be. It might be completely generic, like they just captured this through a honeypot, and then they were like, anything we capture in the honeypot is bad, and then, yeah. No, there's nothing really there. Probably going to be nothing more than hashes on it. Although this is nice. They do give us a link to grab the samples. That's cool. But yeah, that's it. Just the hashes. And whatever everybody else gets it as, which is kind of handy. So let's move on to, we kind of covered the use cases here for daemon versus standalone. But one of the things we might want to do is, when we're using the daemon mode, is to monitor it. And one of the tools we can use for that is called ClamD top, which works just like top. We'll run ClamD scan, but this time I'm going to hit all of etc, right? And we'll see in here the events. Now, this is single threaded, and one of the advantages of running ClamD scan locally on the system like this is that we can actually pass file handles directly to it. And in that scenario, basically what we're doing is we're telling the ClamD scan, the ClamD daemon itself, to go do the scan rather than streaming it into it. But that's something else we can do. And where that comes in valuable when we're talking about streaming is that you can run a ClamD server, right? A dedicated system that's job is to do AV scan, basically AV processing, where you're talking to it over a network. And there's some pretty lightweight modifications that we make to the ClamD scan client. This gets really important when we talk about real time. Right now, we're not doing real time. We're just doing, on demand type, scanning in here. So this time, instead of me passing the file handle to it to go and scan stuff, I'm going to tell it to stream it. So in essence, it's streaming the content into the daemon, and I'm telling it to run multi-threaded. And you'll see this guy here on the left, depending on how quickly this runs, you'll see, see it just bam, it blew through all those threads really fast, and you saw how quickly it did the etc file system. So, just as a ballpark here, we do a time on single threaded, even through the file handle, it does okay. It's already cached in the file system. It's already done some tricks here. Let's do it on like user, because that should have a lot more data. We should be able to see it, right? This is gonna, by default, I think it threads, I think it's caps out at 24, I think, but it's configurable internally, and it helps to speed this process up. Now, where this is really gonna make a difference is when I run this as through the IPS. So a couple other things you can do here with this as a client. I'm doing this totally command line driven, but that means that because we have this client, we can integrate it at service levels. And one of them, if you were eagle-eyed, you might have noticed on this system here, is there is a module for mail servers. And that typically is one of the bigger use cases on Linux that I've seen this used for. Now, obviously, it's catching our rootkit server malware, which is spectacular. That is a very, very key use case, right? Because even though we're not talking, Linux typically doesn't have that same desktop malware attack surface that you would have on typical desktop environments like Macs and Windows. The server malware is a very unique and growing thing you find over there. There's certainly server malware SIGs and CLAM for Windows, but server malware in Linux it can involve all kinds of things like botnet command and control components, or in this case, with what we were looking at last week, is obviously absolutely a botnet, not a command and control node, but a botnet service, right? Part of a larger botnet. And it doesn't, these things don't require privileged access to the environment to do those things. It certainly helps if they have them, but they don't need privileged access. So especially when we're talking about platforms that are have high attack surface, like web services and things like that in the Linux sphere, this is still a good tool for those environments, and we'll get into that with the inline stuff here. But let's take a look at some of the packages that are already out there for this. I thought I saw the corner of my eye. XM, right? So XM is a mail server, an MTA. There are implementations of this for other tools out there. One that I used to maintain way back when was integrations with FTP servers, Pro FTP specifically, but definitely modern FTP servers. Most modern FTP servers have had this for a long time. And my personal favorite place to use it outside of the inline is in web servers. So when we do our mod security, we're going to probably do a bunch of mod security events, but mod security has great implementation of this to be able to scan code coming into the web server that is coming over a post. Mod security itself really isn't the right tool to scan something above a certain size, but CLAM does this gracefully. If you saw me just do all of user, it's great at it. It threads and it does really well. That was how I originally had used this, right? The inline capabilities of ClamAV started evolving and have gone through huge changes over time, but that's probably only really been around for 7 or 8 years or so, and didn't just really get enabled into ClamAV itself until honestly like a month or two ago. Like it's been available if you knew how to do it, but it wasn't implemented raw in the default packages. Now it is. So as of today, right now, you can do inline ClamAV. And I'm going to show you. So the first secret for inline anything in the Linux kernel is a functionality called fan notify. And Cedric Diggory, by the way, is a famous Hufflepuff, if you guys don't know who that is. He later on became a sparkly vampire, and then he became Batman. But anyway, fan notify is kind of if you've ever heard of something called iNotify in Linux, iNotify is a mechanism used in systemd and in all sorts of different applications to basically detect when a file changes in real time. Fan notify pushes that envelope farther out in that I can detect the change, I can hand that in the kernel off to a user land process to make a determination on what we should do with it. And then I can enforce you being able to access it based on what that application has told me. And then I will cache that result in the kernel. And so effectively, that means that you can do real-time file system intrusion prevention, right? I'd call it FIPS, but that acronym is already taken by something else. But effectively, we can connect ClamD to this kernel function and allow us to basically, IPS the file system efficiently, which is really what matters here. That's why it was important that we have a threading service here in the form of ClamTop that will allow us to do this. But more important than all of this is that we move from a reactive model where we're going to scan something, scan it on upload or whatever, or scan it after the fact. This is scanning it whenever the file is, I'm going to use the word air quotes here, accessed. Access means something specific in kernelese, but basically it means that if somebody or some process tries to do something, that's going to be an access, right? A write is not necessarily an access. A write is a write, right? But access means, okay, I've written it, and now I'm going to do something with it. So enough gabbing. I'm going to show you first a live demo of this, and then we'll talk about it. So we're on our live box here. I'm going to become, in a very ghetto way, a different user. I go into the directory called test1. I'll make a subdirectory. Oh, that doesn't exist. And first I'm going to grab an eCar test virus signature. Now, step one, it let me download it. Why did it let me download it, right? The reason why it let me download it is because I can't scan something until I access it, or for that matter, and in order to access it, it has to exist, right? So it has to be on the file system. If I wanted to try to get this at the network layer, this is not the way to do it. You'd need to do some kind of proxy or some kind of integration with the tools. Proxy probably more realistically. But what we'll do here is, I already have that running over here. I might. All right, we'll tail or log messages. We'll grep for ClamD. Okay, so eCar is on the system. I am an unprivileged user, and this is going to be super anticlimactic, but bam. The user can't access the file. Now, this is being done in line from the kernel, right? I didn't have to, basically, I didn't have to do anything other than turn it on and point it at the directories I wanted to watch. On the kernel side, we logged this twice, right? One, we get the ClamD service itself returning the that this particular file had eCar, and the second event is actually coming from the on access scanner itself that's telling us this, right? So now I basically have, it's still there where it was downloaded, but as a, let's call him a make another user here, to add. Our root user has the permit, is excluded from this, right? So I can do that. So functionally, this could let me do create basically an inline forensics capability here. I can always say, wherever that file was uploaded, I want to keep it, right? Which you might want to do, and you might not want to do. I lost one of my windows here, folks. Bear with me. Where are you? There you go. So I'm sure probably one of the questions we'll get after this is, how can I implement a quarantine? And you absolutely can do that. In this scenario here, I don't have it implemented as a quarantine. I want to talk about how this works first and what the next pieces are to it. So let's break down the configuration itself. And we'll go back to our, wherever I put my VM, because my config is not the default at the moment. I want to look at the default config first so we can all kind of get a feel for what you can configure in the ClamAV scan file. as it relates to this. There are a crazy amount of configuration options in Clam. Maybe if you're interested, there are signatures in this that are specific to detecting PII, right? Personally identifiable information, and PAN, personal account number information. So that would be, Clam has native ability to detect things like social security numbers and credit cards, and you can turn that on and off and all kinds of crazy stuff. We're going to go look specifically at the on-demand stuff that I'm going into here, which is called on access, and what the settings are we can do in here. Number one is it does have a limit by default of the maximum size of the file it will scan, right? So 5 megs. As a bad guy, make your malware a little bigger than 5 megs, and you could get around this unless you've gone in and configured that differently. We have our settings on the maximum number of threads. If you're running a ClamD server, pump that up as high as you can go. We have a timeout value here. This is going to be to keep it from introducing some level of, if that ClamD service is out of commission, it would effectively it introduce a lot of latency on the system. Now, the good news is, once a file has been scanned, it does not ever have to be scanned again unless it changes. So if I kept hammering away on that iCar file or whatever, my malware file, it's not gonna introduce any latency. That's the beauty of fan notify. It's cached this data in the kernel. And there is at least one other project that I know of so far that has implemented fan notify, which we're absolutely going to cover. It's called FA Policy D, and it is an application whitelisting system. So you could use fan notify for more than just malware detection. You could actually use it for true application whitelisting. Now, the settings that we want to talk about first are the ones that I use today, which are include path. I said watch a specific directory. There is also the ability to tell it to watch a mount point. I will caution you from doing that against a mount point right away, because there are going to be plenty of services and applications that will that need to be able to manipulate files that may have malware in it. A good example of that is if you're running a mail server, you absolutely would need to allow or basically turn this off for the mail server user, or the mail server will just stop working whenever it hits. I mean, it'll hit malware and then the mail server won't be able to load it, and it'll freak out. It'll cause, cause all kinds of weird errors. So the trick with that is, one, practice with include path first, and then you can set users that you want to exclude by either name or by UID. I always recommend use the UID first. If you're using, if your systems are tied into like an LDAP or free IPA or something like that, by all means, you can use the username. It's just that, play around with this as with the user ID first before you get into that, because the user ID could be different for the same user across multiple systems, right? Actually, that makes a good sale for using the username. So I'm going to use the user ID today. First one is exclude root. I can't think of a scenario yet where I didn't want to exclude root. But I suppose if you're in the super paranoid mode, you could exclude root. You wouldn't be able to access the file as root until you turn ClamD off or reconfigured it or something. But at any rate, I always have that on by default. And then we're going to go and play around with exclude by username. So we can create a let's call him our forensics user, right? Our forensic accounting user. So we're going to add that on this guy. I created a new user over here called test guy 2, I think. My config slightly different. And let's play around with this by username value. What is that? Exclude uname on access exclude. Test guy 2. You have to restart it. No, not service. Mine is slightly different from your setup. If you're using the EPEL packages, do it the way that EPEL recommends to do it, which will be I think they call it ClamAV at scan. Effectively, that model with service with the systemd service files it would allow you to run multiple copies of ClamAV with different configurations. I don't have a good use case for that. I think it's cool though. My setup, I didn't implement that because this is this is a pre-EPEL implementation I'm using over here. And let's test that guy out. So step one, we verify still that everything is working right. Clam is started. Right, he's not allowed to see it. If I become test guy 2, if that setting works the way I think it does, this guy should be allowed to view that file. Yes. Right. So effectively, I've created an exception. Of all my users on the system are prevented from or have this implemented, have real-time malware detection implemented on this mount point. But now I have a particular user. Now the use cases for that: one, mail servers. You should, I mean, you have to. There's no way around this in a mail server if you're implementing this at the file system level. The alternative is to exclude the mail spool and still allow it, right? That would work. You could, I mean, ideally, you still want to scan the mail incoming to the system itself. So you would use it as a client, right? That would be my 2 cents there. I would say as a client, let him use that, and maybe a mix. I mean, there's nothing that precludes you from using it in multiple scenarios. An added bonus of implementing this as a client is that it can return this message here. The odds that for the most part, the clients that I've worked with in FTP and mail, we can return this message to the end user to say, I am blocking you from uploading this file over FTP because it's this signature. Or in a mail server, the mail servers itself could tell, you could send a message that's integrated into it that says, hey, this file was removed from your email because it was malicious, right? Tons of them have been doing that for a long time. Okay, I had a question that was asked before this, before we started here, and unfortunately, I don't think they were able to join us. But can you do this in containers? So first off, in anytime we're talking about fan notify at all, it's Linux centric, right? So this is not a function that exists outside of Linux, and specifically, it exists on Linux kernels made after version 3.10 or 3.8 and up. So for the most part, the raw guts are available to implement this at all, right? Now it depends on, in containers, if we're talking about container environments, like on Windows or Macs, it depends, one, that the kernel is new enough, and it should be. I can't imagine that it isn't anymore. And two, that the kernel has been compiled with fan notify support. So step one to know that is if you can get access to that kernel's config file. Now, again, all Red Hat systems, 7 and up, CentOS systems, Rocky Linux systems, Fedora systems, they can all do this, right? So if you're using those at all, you're fine. Any modern Ubuntu system, probably since 16, maybe even 14, can do it. Debian probably, certainly all the new stuff in Debian can do it. I'd have to see how far back, but here's, if you don't know, and if you're like on a custom spin or something like that, the platform is gonna, hopefully they've compiled the Linux kernel to share their config with you. And I'll show you 2 ways to detect that. And We'll just do it in star. One way is this is a standard done by Red Hat and Fedora. They will have the kernel config file stored under the boot directory, and you can just grep for fan notify in it, and you'll see there's two settings. And I'm going to paste these into Slack for anybody who's following along. The other is that there is a proc device that I haven't used in a very long time. I think it's a kernel dot something. I don't see it. That'll probably give me a ton of stuff. Aha! No, that's not it. That's not what I want. But sometimes there is a kernel proc device that would tell me this too, that would give me the config settings. Again, if you're using a container environment desktop-wise, I'm hoping all the modern ones support it. Okay, so that's number one. The kernel has to support it. Number two, this is 100% a privileged operation in the kernel. So that means you have to pass the capsys admin, and I'll just paste this into Slack. But it's this flag. For anybody viewing the video later on, it is this flag. This is the sysadmin capability flag, and it is basically giving the container a lot of very privileged capabilities it probably doesn't need. That could be used, to abuse the container or Kubernetes environment to escalate their privileges and things like that. So the good news is you can do it. The bad news is as of today, I don't know of any container setting that would allow you to limit it. Now, just doing this on, say, you could still do this. If you're using, for example, persistent storage or some kind of volume mount, you could either from the host platform or from a separate container or something, you could still do it. You could say, hey, I'm going to create a container. I'm going to run this other container that has no attack surface, and its job is just to run clam, and I mount that persistent storage into it. It's a little more of a clue. It's like I said, it's kind of kludgy to do it either way. It may make sense for your environment. It may not make sense for your environment. But as of today, that's the only way to do it. Now, in the future, what I'm hoping is that as this functionality becomes more popular, and as of now, and there's 2 projects using it, which is 2 more than there were 3 years ago. That maybe there'll be a capability flag that just enables fan notify, which would be tight, because we can do. We're doing malware today, but fan notify would allow you to be deterministic for a million different ways. Application whitelisting is a good example. There's one implementation now. There could be others in the future that could do it. All right. Coming up, we've got about 15 minutes less, a little bit less, and I am going to try and do some basic signature writing after we kind of go over the signatures themselves, right? The signature types themselves. Now I'm going to look at a system that I have here. These are RSIGs that we distribute. I'm not on the right system. These are RSIGs that we distribute in our distribution of Clam on the Atomic platform. But I'm going to this is a good example because I don't think they have a lot of these more advanced examples in the default one. I'll look. Or at least if they do, I don't have them turned on at the moment. Yeah, it's pretty simplistic, right? We have what's called the CLD and the CVD files, right? CLD signatures. These are going to be the more complicated of the two, and off the top of my head, I'm not going to try to guess. I'm just going to look. What are the CLDs mapped to again? Been using this forever, and I couldn't tell you right away what they all what the names mean. I have a suite of tools I use to generate signatures. And I'll break some of these down here. So CLDs are, well, just the database format. These are basically these are the more dynamic configs. These are the harder ones, air quotes, harder ones to write. But this is what a malware sig looks like over there. And let's grep for the ones that we found. What are those called here? We had two. Sure, people are getting dizzy by all the screen swapping I'm doing here. Okay, so we had two SIGs over here, and let's look what they used for these real malware SIGs here. Before we start making some, I'm probably gonna make some on a fake one. I'll just find a file. -I on. No, you're not in here, are you? Probably in main. These are the compiled ones over here, so yeah, it's in main probably. Curses, I want to rip that apart, but I can't. But I can look at ours. So let's look at ours and go through some of the way these signatures look. Starting with a hash one. What do I have in here that's hash? There we go. Our honeypot SIGs. So honeypot SIGs are pretty straightforward, right? You've got the original hash value of the file, in this case, MD5. They do support other hash values. They do SHA-1 and SHA-256, if I'm not mistaken. They do SHA-256. Hash basics. Nope. Let's do MD. Let's put in MD5. I think it says like MD5. Yes, they do 256. Why would you use one over the other? Speed, and just bearing in mind that defeating a hash-based signature is very, very easy. But I mean, it doesn't hurt to start with doing a hash-based sig. In terms of processing power, it's negligible, the impact on the platform, and you can whip these suckers up fast. I'll do one real fast for you. So if I wanted to create a, let's do it in our VM. I'm losing track. Yeah, let's use some of these guys right here. These are, let's see which ones of these guys may have SIGs already. We didn't go over this PHP malware in the last week, but each one of these is also malicious, right? They're usually like web shells, and you can see a couple of them. Yep, no SIGs, right? So this is really malicious. Nope, no SIG, no SIG, no SIG, right? None of these guys have, yeah, none of the PHP ones are SIGs. So let's do that. We have a tool that comes with Clam called SIG tool, and it allows me to create a signature. This would let me create signatures in all the formats, but knowing how to create a signature, a binary signature, is a lot more difficult than a hash one. We'll just do a hash one real quick. So we'll do really simple SIG tool MD5 on, let's pick JST OX1. And there's our SIG, right? I literally could do this, and I will do this. I will put this into my malware, my PHP malware. Into, it's called an HDB file. That means hash database. So I put that in the hash database, and I just move it into this directory. I'm going to use user one. I don't even have to restart it. I can just run clam scan on this guy again. And I should, now I can modify this, by the way, and directory, where am I at? Oh, because I just moved it. I can modify this this file here and change this value here. It's using the name, so we're going to do it's my dot example malware. Can't use spaces in this. If you do, it will complain. So we'll do that, and then we'll do. I could cherry pick, by the way, a specific database with this. Clam scan star. So it loads this sucker up. Now, a pro tip: just grab all of your malware SIGs and glob this, and it will create it. And you can see, bam, right there. I've got a signature, a hash signature on this. Let's do that again though, but and look at some of the other options we can get into on this. I realize we only have about 5 minutes left. If there are any questions that I'm not getting into, please let me know. I am trying to check the other channels while I'm doing this, but it's kind of hard. And there's a very long, interesting thread going on in the one of the MITRE channels about the malware we're gonna probably look at in a new session soon. But I wanted to kind of touch on some of the other options in this, and the one that I find is really useful, which is Yara. So this would allow us to generate our what we call I call internally a binary signature. That's doing it in a disservice, but basically in a ClamSig, we can create a signature of the actual binary as it lives on the disk, effectively in looking at machine instructions, right? And you can use that to get around what effectively you call polymorphism, but really what that means is the file is changing all the time to get out ahead of things like static signature analysis, like a hash is very simple, but even binary signatures, right? You're always chasing the malware with tools like this, which is why when we talk about fan notify in the future, it's a way to kind of flip this around, where we're instead of looking for bad, we're only allowing good. But let's take a look at real quick what some of these other SIG files look like. So this is an LDB, which is a more advanced one, where we actually are looking at the structure of it. And I'm sure if this is very daunting to look at, and yeah, it is. Effectively, it is an and and or condition. I can create ands and ors in this to find particular values in the file. Okay, that's cool. It's really hard to write. I get it. The Yara ones though are a totally different story, and I think this is really the one worth learning and worth us doing more on in the future. So this is a Yara SIG. What's cool about this is that I could take this exact same SIG and drop it into any other tool that supports Yara, like network IDS tools will support Yara. Tools like obviously Clam can do it. There are just generic forensics tools that can be used in here. And in Yara, I have a way, one, which is so great, I can dump all kinds of the metadata in here, like a URL about the data, versus if I look at the other Clam format files, it's pretty limited. I have a nice human readable method of analyzing strings, right? This happens to be a PHP centric one, but that doesn't have to be PHP. This could be looking for binary or strings that are in a binary file, and I wouldn't have to write anything for me to understand the binary file. And then I've got things like conditions. I want to see this variable at this point, or that variable, and this thing and that thing. I can also do hashes, and I can even associate scores with these. So I could use this for severity, for example, or something along those lines. I absolutely think this is probably the more usable and approachable signature development language, just because this way you write it in Yara format, you can use it in lots of different environments. It is completely underutilized in Clam today, and I'd like to see that change. A couple of the other ones are in here. Yes, you absolutely can still do hash files with these NDBs, right? Or basically hex. You could look for hex strings or hex values in the file. What I think is always interesting about these is that you can tell you've got two totally different designers working on a particular detection capability, because they'll invert things. Like the string of what it is now at the front, and the value we're looking for is now at the end, right? Versus if I look at the hash one, it's the other way around. And then there was the main.cvd file. This is the primary signature. Well, CVD and CLD. CLD I think is human readable. I think. Yeah, this is going to be human readable, where they're these are actually looking at executable or logical, I suppose you could say, signature types. What I showed in the first part here. All right. On that note, we are at the top of the hour. I want to thank everybody for joining us. I know that a lot of folks are catching this after the fact. Number one, we want to make this a good time for everybody. We at the beginning of the session we talked about moving this to at a different time in the week. Absolutely, have had folks tell me that they're not allowed to use Zoom. Totally understood. We are going to investigate putting this on. Well, we're not going to investigate. We are going to be putting these on YouTube and possibly on Twitch. We might even have a session where we're just talking about our OBS setups, our setups for doing the broadcasting. I had last session. I had a couple of people reach out to me with new malware. Yeah, totally. If you have malware and you want us to go into take it apart, this next one that we're going to do is actually uses eBPF. That's Echo Bravo Polo Foxtrot malware. That is a really powerful attack vector in leveraging a particular part of the kernel that it's fairly recent in addition to the Linux kernel. Super cool. We're totally going to do that one. What we need whenever we're doing these malware reverse engineering efforts, we need the malware, right? I had someone ask me the last week if we could even do live forensics. Yes, we can absolutely do live forensics. I just want to be clear that if we're doing live forensics, we don't know what we're going to find, and if the system is sensitive or you don't want us showing anything on it, probably you don't want us to do live forensics on it. Also, it can take a long time, right? Versus if we already have the malware in hand and it's very easy to load it up into Ghidra. My clumsiness with it notwithstanding, we can usually get through it pretty quickly. So again, I want to thank everybody for joining us. If you want to reach out to us on our Slack channel, it is on atomicorpsupport.slack.com. Anybody who's posted you this link before should be able to give you the sign up to join us over there, so we can have our kind of paste our raw stuff over here. And again, thank you everybody for joining us. I hope to see you again next week. Well, not next week, but the week after next week.
Yeah, you're on vacation.
I'm on vacation next week, so it'll be soon, unless somebody else picks up. And again, it's not just us. If you would like to do your own presentation, you are welcome to.
Thank you, Scott.
All right. Thanks, everybody.
Bye.